Hello,
Yes, Anil, am
I'm
I?
audible?
Yeah, you are audible.
Okay, thank you.
Let us wait for 2 more minutes and then we will start the session. Let us start the session at 9:05. We will wait for some 2 minutes. Meanwhile, anyone voluntarily can unmute yourself and tell me what is core coverage.
Percentage of RTL or the lines of RTL executed or covered.
Okay. Other than Anikesh, can anyone?
Code coverage means how much of code is covered they show. Mostly the code coverage given by the RTL. I mean, simulator, they give that.
Yes. Okay. And what is functional coverage?
Functional coverage means like how much of functionality is covered while writing your test bench using coverage.
Okay. So can we
It's
track
like a functional coverage means saying that
failed test
they
case?
can lines are covered like how much. Hello.
Yeah, can we track the functional coverage for the failed test cases?
No.
Okay. I think we are good to go to start with today's session. We have enough people. And anyone have any doubts related to the previous session?
As of now, no, man.
Okay. Fine, then let us start with today's session. It's almost 9:06. So today, the major focus will be the functional coverage and the code coverage. What is, I can say, the in-depth knowledge. Yesterday we just have saw the introduction, right? So today we will go further. So in code coverage, as we have already discussed, in code coverage there are different types. One is block coverage, and then it is just a minute. It is
Hello.
yes.
Ma'am, actually, today I have to travel at this time, so I'll not be able to attend the entire session. Will Can I get the recording of
Yes,
the session?
we will do that.
Okay.
Yeah.
Thank you.
Yes. So in code coverage, we have different types. That is statement coverage, line coverage, statement or line coverage, one and the same, path coverage, and then block coverage, and then toggle coverage and FSM coverage. So we will cover all this in the code coverage part, and then we will go to the functional coverage. Okay, so as Anikesh and someone else also, Anil Kumar, they all have explained what is code coverage and functional coverage from the knowledge of the previous session. So let us go further. What are the different types of coverage? So statement or line coverage is nothing but, as we all know that in code coverage is nothing but the number of how well our design is exercised, right? So the design is exercised in a sense, then again we'll be having the different types of coverage, right? Means like the line coverage, block coverage. So line coverage is nothing but each line. Means for example, this is a piece of code. If all the lines are covered, if all the statements are covered in this snippet, it means that the statement or the line coverage will be 100%. Usually, as the code coverage goal is to have a 100% right. So it means the statement coverage should be definitely targeted as a 100% itself, because it will ensure that every line is getting covered with respect to the design. Okay. So is it clear, right? The statement or line coverage?
Ma'am, in the design or test bench,
Design.
every line will be covered.
Design.
Only design.
Yeah. So test bench,
Okay.
we will try to give the stimulus in order to exercise the design. So we will always, we are verifying the design, right? Why are we doing this coverage closure and all? It means to verify our design thoroughly. So these are the different metrics to track the progress of our verification, right? So in that case, we have to concentrate the lines in the design, not in the test bench. Okay. So
Okay.
then it is path coverage. In path coverage, we will be having the different paths, for example. But for example, this is the code. In this, we have if block, right? In the if block, again, we have something like sub statements. That is, we are writing a B is equal to E or E is equal to P. That is going inside and it is entering into some case block. So now with this, we will have one path here, and the second path will be this, and the third path will be this, and fourth path, fifth path, sixth path, like this. So we have six different paths. Can everyone please mute your Shiva? I think you forgot to mute. Yes. So now we have n different paths here. So the path coverage is mainly focusing on means like you have done the branch coverage, then why do we need path coverage is the question now. The path coverage will also give the sequence of the operations. In branch coverage, you will only get one sequence, right? But here it is like if this is going this way, and then in KC it is going to the path one. So it means this is one bin. For example, the second one is the path 2. Did we cover this path? Did we cover this path? This way the analysis is done in the path coverage. So in order to cover even this kind of scenarios, the path coverage is needed. As it is very complex, right, to cover all the scenarios. So the path coverage, doing the analysis also is not that easy as statement or line coverage. Because in statement or line coverage, if that particular line is getting executed, that is enough. But in the path coverage, it's not so. It has to come into this if block, and this series of the statements has to be executed in the else part of the things also has to be executed. So based on the scenario, it will vary. So it is little complex in the path coverage. Okay. And next we will.
Ma'am.
Yes.
In the example already, already you said that line coverage, right?
Yes.
In that line coverage, that if else statements are also covered, right?
Yeah.
A piece of code contains some lines are 10 or 15 lines. All lines are covered. Why you are using again like path coverage, right? All in the path coverage also they considered if else statements. In the line coverage also they considered, right?
Yes.
Yeah. Why you are using path coverage? And one more question, you said not branch coverage, right?
Yeah.
Yeah. May I know about it?
Yes, yes. So, as I already said, we have different types of coverages. Why? That is because here in the path coverage, if you see in the description also, the path coverage is considered to be more efficient than branch coverage. It means if you see the branch coverage, it means nothing but like if suppose if and begin end. In this block, we have some statements to be covered. Okay, so through this, you understood that this branch is executed. But if I have a scenario where I want to check whether in the sequence of operations, means first if the parity is odd, then only it will go to the statement, and then it is going, we have some sub block for suppose. Here we don't have as such, we will be having some sub block. So it has to, I want to track basically that path, means it is the parity is odd and we need to compute the parity, and then again I want to check what is the sub condition in this compute parity, all that. So in that way, this path coverage will give us more efficiency. It all depends on the requirement. If my requirement is such a way in that scenario based requirement is set, then I will choose the path coverage more weightage. I will check for the path coverage. If I don't have any such requirement, I just want to see the coverage, then I will go with the simple statement or line coverage. So it all depends on the requirement. Got it?
Branch coverage as well as line coverage both are same.
No, no, no. Line coverage and statement coverage are same. Branch coverage means it is one block. Either it should be if block, or it should be else block, or it should be some begin end block, or it should be some always block. Any of the bunch of statements basically comes under block coverage. Okay. So next we
Okay,
will. Yeah.
you said branch coverage as well as path coverage both are same.
No, path coverage
No.
is different. Okay. So path coverage is the different paths, means the sequence of the scenarios I have mentioned, right? And line or statement coverage means one and the same. And then it comes to the block coverage. The block coverage is nothing but the group of the statements. Okay. So if you see here, we have one always block. So we have one if block. We have one else block. So in the always block, if it is covered means there will be one bin hit. Means for the, we don't call in code coverage as bins. I'm just saying one entity is hit. So block coverage label in will be there. That particular thing will get hit. So we will see the amount of coverage that has been calculated by the simulator. That's how we do. And then we have something called toggle coverage. In toggle coverage, yesterday also we have already saw, right? It means from any variable is there in the toggle coverage that has to be transitioned from either from 0 to 1 or 1 to 0, x to z, z to x, everything possible way it can happen. But for us, the important thing will be from 0 to 1 or 1 to 0. Okay. And in the toggle coverage does not consider the zero delay glitches. So do anyone know what are glitches?
Yeah, ma'am. Glitches, I know.
Yeah, what is a glitch?
Because glitch means when you send the data in the passage clock or before the passage clock or negate clock, if it is get the data, it will be glitches in that.
Yeah.
Maybe it will be in the flip flops. It will be occurred.
No, it's not occur in flip-flops, it occurs in latches because
Sorry, latches, latches.
latches work on the sensitive edge, right? They are edge sensitive. So there could be a more chances of getting glitches. So basically glitches means it should be, there is some short pulse. Even within the time period itself, we will be getting some short pulse. So for those things will not be considered for the toggle coverage. So this information will be mostly if you work on the GLS gate level simulations, there it will be useful for you. So in this, likewise, you will get the report from the code coverage. This is a snippet of a cadence tool. So here, if you see, we have block coverage, toggle coverage, FSM coverage, all that, right? So here, if you see the toggle coverage, there is something called 71.43%. Means here it is like overall 10 out of 14. Means of the 14 combinations, only 10 are hit. That's why this is the percentage calculation. Means for example, you can think like if the variable is suppose two down, just it's a bit, variable as a. Okay, so it means it has a possibility of either from 0 to 1 or from 1 to 0. But if there is a possibility of like there could be vectors, right? Means we can have a higher width of the variables also. Like we have something like 3 down to 0, a, like that we have. In that way, what it will do is it will check a of 0. A of 0 is transitioning from 0 to 1 or 1 to 0. That will be considered as one possibility. And then it will see a of 1. Likewise, it will check for a of 2. Likewise, it will check for a of 2 and a of 3. Like that, 3 down to 0 means how many combinations? 2 power 4, right? Means you will be having from 0 to 15 combinations. So it will see for a of 0, a of 1, a of 2, likewise up to a of 15, and it will club the entire thing and then it will give the report. So likewise, the toggle things are generated. Okay, is it clear? The toggle coverage?
How it will be generated? No? You guys, just we can write a of 0, a of 1, a of 2 up to a of 15. Is it okay with that?
Basically, you will just declare the variable and you will on the code coverage to the simulator. The code coverage simulator will give us this report, right? And when you see the each variable, for example, you click this toggle and now you found that there are 10 out of 14, right? So it means you will see that particular variable which is not getting toggled. So then you will also see, right, a of 0 and a of, there could be a, for example, we have a variable and it a of 0 and a of 1 are not covered. Everything else is getting toggled. So at this point, you will understand this what I'm explaining at the industry level. How do we check? So at the A of 0 and A of 1 are not covered, right? So then you will go into the design and see why this A of 0 and A of 1 are not covered. They're either they could be tied to 0 or they could be not used. Means, for example, we in I square C we are working for suppose in a protocol and we are trying to exercise a different addressing mode, 10-bit addressing mode, 7-bit addressing mode. So the 10-bit addressing mode we are not using at all. We are only using the 7-bit addressing mode. So if you are using only the 7-bit addressing mode, the 7-bit the 10-bit addressing mode variable will not toggle, right? So that way you have to understand, okay, this specific, we are not using this feature. That's why this is not getting toggled. So you have to check with the designer what your conclusion you have done is right or not. And based on that, you will create an exclusion list where you will include that only 0 and 1 are not getting toggled. That is because we have reasons. You have to mention the reason also, and then only you have to add that particular variable in the exclusion list. Through that, the designer will accept that, okay, these are the valid reasons. Then only you can put them in the exclusion list. Then you can see that here the toggle will be getting covered because you will put that in exclusion list, right? So your code coverage number will increase. So first, initially, you have to give the simulator. You have to observe what are there, what is the report, and whichever are 100%, you need or they are already covered. Which are not covered, those things you have to analyze this way and talk to the designer, and then you have to take the necessary course of action. So that's how the entire process goes in an industry for the toggle coverage or any of the coverage as suppose. But for toggle coverage, I got a chance to explain, so I'm telling you here. Is it clear?
Out of 14, 10 will be covered. How you know that remaining, what are the remaining 4 variables are not covered? 4 bins are not covered.
Yeah,
How do we know that the particular bins, 4 bins only not covered? How do you know that? How do you know?
yeah. So you can click on this in the if you have a real-time tool, there you can click on that particular toggle and then you will get the information for which variables it is not for which variables it is not covered. So there you will be seeing for example u of 0 as here as 0%. So it means this is not covered. A of 1 is not covered. So whichever are not covered, that you will see the variable, why we are using this variable in our design. So what is the purpose of the this variable in the design? Then you will go and see, for example, we are using an address of 31 down to 0. So So here,
One more question, ma'am. If you are using 32-bit, right?
yeah.
At that time, if you want to cover all the bins, up to 32-bit means like how much, ma'am? 6 to 535, right?
Yeah.
Yeah. Is it possible to check that all the 6 to 535 bins every time?
We will not check that, right? Only the simulator will check that.
Yeah. That simulator will check
Yeah.
again. How many bins are covered? If for suppose out of 62,535, only 40,000 will covered. Remaining 20,000 which is not covered. Is it possible to check what 20,000 it will be not covered?
See, there could be a reason it will directly show us, like for example, 32-bit data is there, it is not toggling. That is because maybe half of the, for example, if we are considering it as some aligned address or something, okay? In that, we can write a reason that only the lower bits are not used. We can understand from the design, like why these bits are not covered. So based on that, we can think that these lower bits are not covered. So you can directly include that 16 down to 0 as lower bits if we are not using it or there could be something like if it is aligned address modulus 4 of 0 whatever is there, those only will be covered, others will not be covered. So for that you need to put a reason and then you have to include that number of bits in the exclusion list. Likewise you have to do it. It's not a hard
So in
that everything has to be covered, right? Yes, Sudha, you can.
yeah. So in real time, like what will be the tool to check this?
What will be
Like a VCS based on that vendors are based on the clients. If you are working the cadence or something, we have to use the VCS or synopsis somewhere. Based on the vendors, we have to use.
Okay.
Thank you, Anil, for answering. Sudha, that's true. It all depends which tool we get.
Yeah. Okay.
This is the cadence tool snippet which I have taken. But in every tool, you will have a clear report. Based on that, you can work. That's not. Just it will be user comfortable only. Just by seeing that, you will understand. You can just go on the flow. Okay. So next, we will go through the FSM coverage. In FSM coverage, the two things are there. One is that all the states are covered or not, and the other thing is that the transition is done or not. For example, here we have in FSM state ideal, setup, access, and wait, right? So there are 4 states basically. So first part will be like whether ideal state has hit at at least once or not, and setup, access, weight, all this, that is one kind of coverage in the FSM, one aspect. The other aspect is from ideal to setup, it has gone or not, for ideal to access. There could be a case, right? There is not necessary that ideal to weight it should go. So in that case, we can include that part of the scenario in the exclusion, because we don't have such scenario in the specification or anywhere where, or we don't have such requirement at all that ideal should go to the weight. So in that case, you can write a proper reason for that and then you can add that into an exclusion. So when you give it to the tool will not do anything. Tool is a robot, right? So it will just check that whether it is all the combinations are happening or not. So as a verification engineer, we should put our thought to understand as we know the design. As you know the design, I know the design. So I will think that why there is no requirement at all to go from ideal to weight. So why is it showing this? In that case, you have to exclude it by giving a proper reason. So that's how any verification engineer has to think. So before doing any coverage plan, in most of the industry, first they will ask you if you are assigned with some coverage task, for suppose, they will ask you to create a coverage plan. How will you create the coverage plan is first you will understand the entire design or the specifications. Through that, you will have a rough idea. Initially, you will have a rough idea for a coverage plan. Later on, you keep on increasing that based on your understanding. Your understanding will keep on increasing, right, by working on the project further. So then you have to update your coverage plan. Initially, you have to create a rough coverage plan. Based on the understanding, you have to update that. Okay, here this requirement is not there, so we don't need this. Or there could be some special cases. You may think that this is some priority feature you would have observed in the test plan. Everyone is focusing on that. then you have to note down even your coverage plan note, right? Like this thing I need to sample. So this thing I need to cover. This scenario should be covered at any cost. So if you note that way, you will not miss the important things. So that's how the coverage plan is done. So this is about the code coverage. Next, we'll go to functional coverage. Before that, anyone have any doubts? Let me check in the
So how can we write this code coverage? Like automatically, tool will detect this.
Yes, automatically tool will give the code coverage report. Based on the code coverage report, if you want to do any changes, for example, I have explained right in the toggle coverage, like that analysis we need to do and we need to add the exclusions. Things. The other way is, for example, everything is proper, means from the design way also it is saying that it should be covered. Everything has to be done. In that case, you have to go to your test bench or the stimulus. You need to improve your stimulus and make sure that that particular piece of code is getting covered. For example, you didn't create a stimulus at all. So in a scenario where, for example, we will see this FSM only. Here this is an FSM, right? In the code coverage, if you were thinking that you didn't in your test bench you didn't provide a stimulus at all, where from the reset condition it has to go to the next condition, means at the reset condition it will be in ideal state. If the p select is high, then only it will go to the setup state. For example, I didn't give this p select high at any point of time in my stimulus, so it will not go into this piece of code, right? So this will not get covered. So that's how you need to analyze and you have to improve your stimulus. So these are the two ways where you can improve your code coverage. Is it
Ma'am, can you show one demo of any of these coverage in the tool, how to do and how to run, how we will get that?
here for the code coverage? I don't have any means like a tool because in the EDA we cannot have the demo of the code coverage, but functional coverage we can do that. So that is why I have given this snippet of the report. So this is how it looks in any of the tools, like how the coverage is done, all that. But at this short span, in this 10 days of the span, I cannot show the entire how it will work and all. But with this much of knowledge, at anywhere you can drive working on it. But for functional coverage, we will practically work on some codes and see how the bins are hitting all that. Okay.
Okay, thank you.
Yeah. So then this is all about the code coverage, different types of code coverage. And then we will see about the functional coverage. Why the functional coverage has gained more significance. Means there is this kind of scenario also, right? We can write, for suppose I have 10 features, I will write 10 test cases. With that, all the functionalities are, if my 10 test cases are passing, so I can state that, okay, my verification is done, right? Why should we have, why should we need to collect the coverage only to verify the design is functionally correct or not through functional coverage itself? I can do this way, right? Writing, I have 10 features, so I will write 10 test cases to cover all the functionalities. So then why do we need functional coverage? Can anyone answer that? Sudha, will you give a try? Hello.
So
We have the
functional
we
coverage,
are writing the test cases for the functional coverage means how
it
much
is
of that
used to verify the
functionality will be
quality of.
covered.
Ani, can you just mute yourself? After Sudha, you can tell. Okay. Yeah, Sudha, go ahead.
So functional coverage, it is used to measure the quality of verification.
Yeah. We can even do this way, right? We for suppose you have 10 features, you can write 10 test cases. So why do we need the functional coverage? You can say that the functional coverage is quality of design, right? Means how many features are exercised. That information functional coverage will give. But you can even do this way, right? You can just execute all 10 test cases and you can say that all 10 features are verified. Why do we need to choose?
Like what if our test cases are more? So it will be very difficult for us to verify all the test cases. at that time.
It's partly correct. Anil, you want to say something?
No.
Okay. So in functional coverage, what is the main advantage is that, so we all know that there are two types of verification. One is direct verification, other one is constraint random verification. If suppose anyone doesn't know it, let me tell you about that. That is directed verification means you are writing a particular direct test case. Means you have 10 features, you will write 10 test cases. But with that, there could be a situation where you will be missing some corner test cases. For that, we are having something called constraint random verification. For suppose there is something called like data bits, if I say, we have some feature called differential data bits. Means the data bits can have 8 data bits, 10 data bits, 15 data bits like that. Okay. In that case, what I will do, I will not write like one test case to test the data bits as 5 and other test case to check the data bits are 10. Like that, I will not do it, right? What will I do? I will create a random variable for data bits in my base test or somewhere and or in a global config, and then I will randomize this data bits, right? So when I randomize this data bits, each time it runs, it will have a new seed value. So when I have a new seed value, it means every time it will generate differential database. So same test case I will use by using a constraint random verification. Each time it will generate a different database. First time it might generate 8 database, second time 10, second time third time 12, like that. So collectively we can have this functional coverage also. So we understood directed verification, we understood constraint random verification, but how is this related to functional coverage? So when it is randomized like this, so if you put a functional, if you enable the functional coverage for that particular number of test cases, so with a single test case only, in functional coverage, I will write a bin for database. And I will write like the data bins, I will write some bin like the bin should be one is 8, the other is 10, the other is 12. So this way what I will understand is by running this functional coverage, okay, as I have done the randomization, so through this data bits cover 8, 10 and 12 are covered. If suppose any of the bin is not covered, it means that I need to increase the count of the regression so that it will track any of these bits. So through this, the functional coverage also we can track that how many features are not exercised. As Sudha said, if there are so many test cases, I can't keep on writing each test case for the each feature, right? So that's why we got into this constraint random verification, and that's where the functional coverage has got it more significant than the code coverage in covering the this how to effectively verify the design. So this is a whole idea for the functional coverage. Okay. So then before, I think we need to join in next session. So before that, anyone have any queries, we can discuss. Fine. So in the functional coverage, system Verilog basically provides two ways to check the functional verification of the design. One is through cover group. So the cover group, which is used from the information from the transactor, monitor, or the checker, right? From these, the information is collected and is sent to the coverage collector. So either we can have a different coverage class where we can have the different cover groups, cover bins, everything, etc. Right? And the other way is the assertion coverage. The assertion coverage is nothing but yesterday, as in the intro I have mentioned, right? This is some temporal language to get the kind of scenario which you are trying to target, the scenario you will write in the system assertion language. Means, for example, one sequence has to be coming after 2 clock cycles. So you will write something like this sequence 1 should come after 2 clock cycles, means we have to provide this 2 hash delay. after 2 clock cycles, the S2 has to come. Likewise, if I mention. So it means it will say that S1 is high after 2 clock cycle, S2 should be high. So this kind of language we will write in an assertion to cover the functional verification. Okay. So we will go through that further. Guys, shall we join the same session once again? Just leave the session and join the session once again because the session will end in some 2 minutes.
Okay, ma'am. Same link?
Yeah, same link.
Okay.
Okay, in the functional coverage, so now we understood what is code coverage, what are the different types of code coverage, and in functional coverage, why exactly the functional coverage has got so much significance in the verification. So all these things we have gone through, right? So now we will see functional coverage, what are the things which we need to understand in order to create a proper. Okay. Okay, then let's go through this. So in functional coverage, we have something called cover group, which is nothing but like how we will have module and module, program and program. Like this, we have some program block, module block like that, right? In the same way, we have cover group. Cover group and end group will be having. So this cover group will have the all the coverage model specification, whatever required models coverage model is it that we will be having inside this cover group. So you will be having a doubt like this cover group where and all we can use it means where and all we can write that. So inside a program you can write inside a class you can write and inside interface or any module you can enclose your cover group. So in cover group, what all things again we'll be having as like in class we have different properties, right? In that way, in cover group, what all we have? We have some coverage points we have. So the coverage points we can have like it could be the cross coverage between the coverage points, anything we can have. So in the coverage, we also have something like clocking event. So we have a cover group. Then when should we trigger this cover group exactly? So that event we can give through the clocking event in the coverage group. If you are not providing that clocking event, then we have to sample that particular cover group at some instance. So we will see all this in detail. Don't worry. It is as it is new to you. Maybe it will be overhead, but we will see the practical examples when it won't be that much overhead to any of you. Okay. And then we'll be having some coverage options, and then we'll be something having something like optional formal arguments. So all this will be having in a cover group basically. And then we will see the syntax of a cover group. So as I already mentioned, we'll be having something like cover group. Here you need to give the coverage model name. Means for example, you are giving some cover group for monitoring some I2C bus speed. So you can give that. Or always you have to prefer the cover group names as meaningful so that everyone will understand. For example, you are doing the coverage for spy. So you can mention like spy CG, spy underscore CG. So with that, the spy, this is for spy protocol, and the CG means the cover group as a short form. Everyone will be using that. So I already told that there will be having some clocking event, right? So means the cover group name at the clocking event. Clocking event means either it should be a positive clock or negative clock or whatever it is. So at that point, this cover group will trigger likewise. And then, sorry. And then we'll be also having in a cover group, we can put some list of arguments. So all these, when we try some practical examples, you will understand, but it shouldn't be very new to you, right? When you try some practical examples, so that's why we are covering the basic syntax for that. Okay. So now let's see what all exactly a coverage file will have. So for example, I have declared two variables. One is address of 1 down to 0 and the data is of 7 down to 0. This is a bit. So here I have declared one cover group. As I said, like module and end module, we will be having some cover group and end group. So the cover group, I have taken the name as CG here at the rate of POSH clock. So this POSH clock is nothing but the clocking event. Okay. So then inside this cover group, I have taken two cover points. So this A column and B column, these are nothing but the labels. So if you doesn't provide any label, then the tool will provide its own label of some, it won't be meaningful if it provides by the tool, because you will not understand what exactly this cover group is, cover point is while debugging. So it is always recommended to give the labels, so that if you give the label while debugging, if you see some the label this is not covered, then directly you can come to the code and you can find out like, okay, this is the thing which I am missing, so I have to cover this, we have to do some analysis. That's how you can start, right? So always it is recommended to have the labels. So then I am declaring a cover point as address and then cover point as data. Here I am not providing any bins, nothing. So it's just a simple syntax, okay? And like how we create a class, right? We will take an instance of the class and we create it, right? In the same way, we need to do with the cover group as well. So with the cover group name, and this is the cover group instance name. So just by writing this way, this COV is my instance name. Why do we create an object anywhere you want to access further, right? Then you need this cover group, right? That's why you will write CG COV as new, and then using this instance, you will sample it. So COV dot sample. So this is the major things you should know. If you get some coverage file also, you will be finding all this. So you should know what is doing what. So even though you are not writing a coverage file, but anyone giving you a coverage file also, you should be able to analyze, right? So for that, you should have at least this much minimal knowledge. Then you will, based on that different specification and all, you will go on the flow. Okay. Is it clear so far?
Yes, yes.
So
Yes.
can anyone say, what can I ask? What is the clocking event at the cover group?
Postage clock.
Okay. And can we have, how many cover points can we have in a cover group?
2.
But
Address data.
it is two, but you can have n number of cover groups in cover points in a cover group. Okay, so that
If
is
you are not using sample, can we create the cover group? Can we access the cover group if not sample?
sorry.
If you are not using sample, can we access the cover points?
No, after writing all the cover points, if you use this cover dot sample, then only your coverage will get triggered. Means whatever cover points which we have written.
Okay.
Got it, right? So then, so that's the next question. Like, what is a cover point basically? A cover point is nothing but a variable that has to be covered or sampled through the cover group. So, what are things you want to cover? For example, we have saw one example, right, about the data bits. For example, I want to cover the data bits. So, it means that I have to mention the cover point as data bits, and I have to give which all data bits I want to cover. What are the differential data bits I want to cover? All this information you will find with the cover point. So here it is like how many cover points a cover group can have. It could be n number. There has no limit for that. So and again we have a cover point. So now I set the data bits as a cover point. So in the data bits as a cover point, how many things we can have like a bins over there? That is also n number. If you are not mentioning any bins, it means that it will take by itself by tool. We will cover that further. But for now, you can think that cover point can have any number of bins and a cover group can have any number of cover points. So this should be clear for everyone. Okay. So in the cover points also, we have again three different types of cover points. And that is one is the item functional cover points. That means so if I want to cover some variable A, with I will give some individual numbers. The A value should be covered with 4, then 5, then 10, or some range also you can give like 30 to 40, like this. So now this will cover only the individual items. So this item will be having only these things. If they are covered, it means that it will give 100%. Means A value should be getting 4 ones, 5 ones, 10 ones, and within 30 to 40 range should be also be covered. In that case, the cover point, this coverage is hit. So this is one way. What is a cross functional cover point is, for example, we have one more cover point B saying that I want something like 2 and 20. So now I have two cover points. So now if I want to do the coverage very efficiently, then what I will do is cross of A and B. So with this, what will happen is it will do the probability checking like 4 and 2. A value should be 4 and B value should be 2. This is one scenario. And the A value should be 4 and B value should be 20. This is one scenario. Then A value should be 5 and B value should be 2 and B value should be 20 when A is 5. So this how scenario, if you want to do it manually, how tough it is. So the system Verilog in the functional coverage, it provides this mechanism just by writing a single line cross of A comma B. So this is very efficient, right? So this is one of the cross functional cover point. The other one is transitional cover point. That means I can write something like if for suppose A value is there and A value, I will write something like 4 after transition you will be having 20. So my scenario is like A should be getting a value 4 and after that as soon as the 4 is done the 20 should come. In this way this is called something like transition. Again I will write like first I want to there is a scenario first I want to check the standard speed is working or not. So first I will check for standard and then if standard has no issues then I want to check for path plus. This is my scenario. So in that way what I will write the standard transition after that the fast then after that fs fast speed plus. Likewise I can create a scenarios based on your requirement. So the functional coverage has provided us these many facilities. It's up to us how efficiently we use it and what is our requirement. Okay, is it clear so far? Hello.
It's a syntax of transitional cover points. Can you write it?
Sorry.
Like transitional cover point syntax. You write the formula like that.
Yeah.
Can you write once again?
That we will see in the practical coding. This is just for an information like so like some implication it will be and after that it will be for example 10 and then it will be 20 like this. We will cover one practical code for all this so that it will be very clear for everyone. Just this is our theoretical gesture to understand clearly what it is what. Okay. Okay. So then we will see further. So we have covered so far what are the different, what are the things we have in functional coverage, right? So I want to, there are some experience standards are also there, right? So all the basics will might bore them also. So that's why I have picked some industry specific guidelines for functional coverage. So how your functional coverage should be basically. So your test plan should be in such a way that it is covering all the functionalities. So that is first step. And the second step is like, as I told you that based on your test plan and the RS, you have to create a rough coverage plan initially. For everyone, the coverage plan, it won't be matured at the first stage itself. First, you will create a rough plan and based on your understanding, you keep on increasing the level of the coverage plan. And your test bench environment should be having a mechanism like you can enable the coverage or disable the coverage. That is because why do we need this feature of enabling and disabling the coverages? Initially, at the first stage of the verification, for suppose I have written all the test cases, and the test cases are some are passing and some are failing. So at that point, if I enable my coverage, so it will be overhead, right? Already you are not clear with the test cases, or you have some so many bugs. So first you need to clear all the bugs. So at that point, you will disable the coverage, and slowly, if you see that the bug rate is decreasing, at that point you will slowly start this coverage enabling, so that you can parallelly work on both. So for the test cases which are passing, for those you can track the information of the coverage, and so on. You can continue with the work. So that's why your environment should be flexible enough to enable and disable the coverage. Okay. So that is what here it is mentioned. Like we should enable the functional coverage at the beginning of the verification. We shouldn't actually. I by mistakenly told we should. So with this is the basic guidelines anyone should know as a ASIC verification engineer, when to enable the coverage and when exactly you should start the coverage analysis. All this. Okay. Any doubts regarding this? Okay. So I already told this, right? The functional coverage plan should be updated. Initially, it will be very rough, and then slowly, based on your understanding, you have to improve your coverage plan. So, and the most recommended thing is the cover group and the cover points, whatever names. Not only as cover group, cover points, any design or any verification you are doing, any test case you are developing, everywhere the test name should be very means meaningful. Means anyone, if I come and see your test case, I should understand, okay, this test is for write and read, this test is for read and write. So likewise, your test name should specify as what exactly this test is doing. So that will create an impression on you, like how sensible you are writing some comments. All these things we have to use while writing a test case or any cover group or any cover points. So this will also help you while debugging also. Okay, this cover bin is not covered. I know because this name itself is telling that the differential database. Means there are, it is not covering the different database. Then you will go and check in the bin, okay, what are the things are covering, what are not covering. Like that you can analyze. Okay. And then this we have discussed in our introduction session only, that the coverage cannot be captured on the failing simulations. Only for passing simulations we will be capturing the coverage. Okay, and there could be a scenario your tests are keep on exercising the same logic, and it is not focusing on the some dead codes. So those things also we have to keep in your mind, like which are the dead codes, why it is going to the dead code. Means something like default condition is there, it is never hitting that condition, because either of the one of the options in your case statements are getting covered. So the default statement is not getting covered. So that all these things you can keep in your mind while creating your coverage file. Okay. So then comes up to coverage bins. As I said, we have a cover group. Inside cover group, we have cover points. Inside cover points, we have coverage bins, right? So what are these bins are necessary for us? As we saw already, like the bins are used to collect the coverage information, right? For a particular feature, what are the things you want to cover specifically, that you will mention in the bins. So as I've already shown you, like in bins, we can either give a single value or you can give in a range also. So the bins can be automated or you can explicitly write the bins also. So how is that? All that we will see. So today we will see only two bins. One is implicit bins and explicit bins. We have so other things also. If I tell everything on the same day, it will be very confusing to everyone, right? So that's why we will stop with the implicit bins and explicit bins, and then later tomorrow we will cover all the practical aspects of the functional coverage and everything like transition bins, cross coverage. All this we will try to execute through code and analyze the outputs. Okay. So in implicit means it's nothing but here if you see, I said right, we can enclose the cover group inside a class, module, anywhere. So here in this example, we are enclosing the cover group in a class and end class. So here we have something like address, which is of 2 down to 0 width. So in the cover group here, as I mentioned, we need to put labels. So that here the label is C1. And the cover point, we are writing address. Okay. So here I'm not specifying any bins. It means the implicit bins. So if you don't specify any bins, the tool will automatically generate the bins. How will it generate? So as it is 2 down to 0, right? Means 3 bit. So 3 bit means 2. You will be having how many combinations, total combinations. Based on that, the number of bins will be generated. So it is 2 down to 0 means 2 power 3. So total 8 bits. 8 possibilities are there. That is 0 to 7. So all these things will be generated for address. It will check like address is 0 or not, address is 1 or not, address is 2 or not. So based on that, if any of the bins are missing, it will reduce the coverage thing and it will give us a result. So that's how it is. Here we have created the coverage also. This cover group, I told right, we need to create it and then we need to sample it. Okay. So this is the implicit bins. And then we have something like explicit bins. Means in implicit bins, you will not give anything, just you will declare like this. So based on the possibilities, it will itself generate. Then it is explicit means I will give by myself. I have such requirement where I have to cover only these. Okay. For example, bins A is 0 down to 3. I have given it here like it should cover 0, 1, 2, and 3. All these things it has to cover. I am giving a range here. Okay. And the other one is B. Like this, if I give it is subscript as empty, no, that is also automated bin it will take. So now it will take B of 1 should be 4, B of 2 should be 5. So like that it will take. Okay. Based on the range which we give and based on the subscript it will take. If I mention some subscript, then it will check like C of 2, 1 is 6 or not. Then C of 2 is 7, 8. Like that it will take. Okay. So these are the different kinds of bins which we have. So we will cover further in next sessions in the practical coding also. So far, any doubts? We will summarize once what all we have covered today, and then we will wind up the session. Is everyone there?
Yes, yes.
Yeah.
Yes, ma'am.
Okay, let's.
So, ma'am, in real time, we will use explicit bins
No,
in
it
real time.
depends. For example, I have a requirement here address. If we see implicit bins only, address is there. I don't have any specific requirement that address value should be having some value like 30 or I should have some value like 20. I don't have any such specific requirement. Then I will simply declare cover pointer's address. With this, it will cover all the possibilities. Once after the possibilities are done, then I will check the report. If I don't have any specific requirement, I should make sure that it covers all the possibilities. Means I need to increase the randomization count. With that, it will cover all the possibilities. That way, it will work. It's even in industry level also we use implicit bins, explicit bins. Everything we use. Just that about your requirement, it varies which thing you have to choose.
Yeah. Okay.
Okay. What about others? I can see Sudha, Amit, not Amit, Aditya and Anikesh. These people are active. What about others? Do you have any questions? Vishali, is it clear with
Oh,
everything? Sorry, someone. You can go ahead. Someone has unmuted, right? Hello. So, can we wind up the session or anyone has any doubts?
No doubt.
Okay. So let me summarize. Actually, yesterday one of the candidates have asked to summarize at the end of the session. So let me summarize for you all. Like today we have saw the different types of code coverage. In code coverage, what exactly we have saw is the statement coverage, path coverage, then block coverage, then FSM coverage. All this we have covered in the code coverage. And then we saw some snippet of the code coverage, how exactly at the industry level we have the snippet. So that we have saw. And then why do we need functional coverage when we had a option of just creating a test cases for particular feature, but why the functional coverage has got its more significance. What is directed verification we saw, and what is a constraint random verification, how the coverage is related to the constraint random verification, all this we saw. And then what are the things which we have in the functional coverage, means if we want to write a coverage file, what exactly some idea we should have, like cover group, what are cover points we saw, and then what are the coverage bins, what are the different types of bins we have, and what are the industry specific guidelines to create a functional coverage. So all these things we have gone through in today's session. So tomorrow we'll go through more about the functional coverage practical codes. So if you have any questions, you can even post in the group or you can ask right now. Otherwise, we will wind up the session for today. Okay. How did you all like the session? Did you like the session or do you need any improvements?
Like
So far, it's good, ma'am. Like as we are going from a basics, like
Yeah.
it is good. But maybe when we go even for like further classes,
Yeah.
like we can have more practical and
Yeah.
real time.
Tomorrow we will concentrate on the functional coverage coding part only. So for
Yeah,
today, we have just covered a theory part and all. Okay.
yeah.
Mm. What about others? I can hear from Sudha, Anil, but others don't interact. I prefer the session to be interactive. This that will be more beneficial to you only, not to me. Like today, Anil has asked some two questions, which got me to tell different industry related things also. If you guys ask questions, it is beneficial to you, not to me. Right? Okay, then let us end the session for today.
okay, madam.
Okay.